Good morning, students. Today we are discussing about applied geotechnical engineering 18 CV 62 module 4 lecture class 4 for 6 semester students. Today's our discussions are factor affecting bearing capacity of the soil. The following are the factors which are affecting bearing capacity of the soil. One is type of the soil, physical characteristics of the foundation, soil properties, type of foundation, water table, amount of settlement and eccentricity of loading. So type of the soil. So each soil will have different C and phi value. As the C value changes, bearing capacity changes, phi value changes, bearing capacity changes. Some soil, if the C value is there and phi value is not there, bearing capacity will be different. Some soil phi is maximum, C is 0, the bearing capacity is different. For example, for pure positionless soil, C is 0 and ultimate bearing capacity is that is gamma df into half gamma bnr. Whereas for pure frictional cohesive soil, phi is 0, then nc is 5.7, into is 1 and gamma is 0, then qu is 5.7 c into gamma df. So next, physical characteristics of soil. Physical characteristics means the width of the foundation, depth of the foundation, shape of the footing, the foundation effect on the bearing capacity. As I said earlier, Qf is equal to CNC gamma df into half gamma bnr. The width and depth is directly proportional to ultimate bearing capacity. There are some soils when the width is increases, bearing capacity increases, or both width and depth increases, bearing capacity increases, or depth increases, bearing capacity increases. Okay, some of the examples are for square footing, that is Qf is equal to 1.3 CNC, 1.3 CNC gamma df into plus 0.4 gamma bnr. For circular footing, 1.3 CNC gamma df into 0.3 gamma bnr. So soil properties. The soil property like shear strength, density, permeability, etc. affect the bearing capacity of the soil. Higher the permeability, lower will be the strength carrying capacity of the soil, or vice versa. For example, if you consider clay soil, permeability is low, but the strength carrying capacity is also low. Whereas for sandy soil, permeability is high, strength carrying capacity is also high because directly proportional. Okay, so dense sand will have more bearing capacity than loose sand. Among the sand, again it varies. Dense sand means, so that is the density is high, jump packed, therefore strength carrying capacity is high. Next is type of foundation. Type of foundation selected also affect the bearing capacity of soil. Raft foundation or mat foundation adapted support the load of structure safely by spreading load to a wider area even if the soil is having low bearing capacity. In the low bearing capacity soil, if you provide isolated footing, the load carrying capacity it reduces, whereas if you provide a raft foundation, load carrying capacity increases. That's why type of foundation also plays. Water table. Generally, presence of water table reduces the bearing capacity by around 33 to 50%. Okay, if you take an equation, Q ultimate is equal to CNC plus gamma df into RW1 plus gamma of gamma bnr RW2, whereas RW1 RW2 is water table correction factor above the base of the footing and below the base of the footing respectively. To substitute it, around 33 to 50% bearing capacity get reduces. Amount of settlement. Amount of settlement of structure also affects the bearing capacity of soil. If the settlement exceeds the permissible limit, the bearing capacities also get reduced drastically. So eccentricity. So concentric load will have higher bearing capacity than eccentric load because of the uneven distribution of stresses below the footing. So that is A, instead of A is equal to B into L, it get reduces to A is equal to B dash into L dash. So some of the MC questions are the bearing capacity of soil is affected by only type of soil, it is B. Bearing capacity of soil is affected only by physical characteristics, is B. Bearing capacity of soil affected by only soil property, B. Bearing capacity affected only by type of foundation, B. Bearing capacity affected only by water table, B. Bearing capacity affected only by amount of settlement, B. Bearing capacity affected only by eccentricity of loading, B. Bearing capacity affected by all the parameter like physical properties of soil, type of foundation, water table, amount and settlement, exchange loading, etc. That is A. The purely cohesive soil phi is equal to 0. The value of bearing capacity is NC 5.7. That is B. Improper. That is the question. For purely cohesive soil phi is equal to 0. NC NQ is equal to NRI is equal to 0. That is cohesive soil phi is equal to 0. So it is false. So these are all the list of references we have taken for preparing this material. We take this opportunity to thank the Department of Collegiate and Technical Education, higher officers and students for giving me an opportunity to deliver the lecture. So I request all the students to go through the LMS content in this subject, and if you have any doubt, you please feel to ask.